Let's start recording. Welcome. We're getting going here. I wish I was like one of those training things with like fancy backgrounds and, did a really fabo job with this thing. It's not kind of who I am, what I am right now. The purpose of this is to share some knowledge on a topic that I know people don't know well. I know CCIEs that are skittish around multicast because they're sort of like, yeah, I know some basics and, as far as it goes. So, and I recognize, let's face it too, that not everyone needs to know this. You can work years and never run into it, never have an application that calls for it. You could be hip deep in it. Some industries, my understanding is, particularly around stock trading, where they love it because the idea with multicast is simultaneous delivery. I don't have every machine on the trading floor getting in the sequence. Machine 1, machine 2, machine 3, machine 4. I send it out, they get it essentially simultaneously. It's the same packet getting copied to all the machines, not different streams. And healthcare, you can run into it. Traditionally, where there's been a product, Vocera, you'll see it hangs around the neck of the staff in hospitals, and it's a communication device. It uses wireless. And when they do a broadcast, so normally they press a little button, they say, call, Betty Jones. Calling Betty Jones. She'll pick up. Right. And they're super useful. They're things like the nurse working wards. Patient hits their call button. Normally, traditionally, they'd have to be sitting at the desk to get that call. Now they can be out working on their patients and get a call like, can you turn me over? I got to use the bathroom. Whatever it is, whatever their need is, they can answer it. If they were just chit-chatting with a patient and they can, take care of that. Hey, can I, do you mind? I'm going to go help him with, go to the bathroom. They're like, sure, I'm fine. That's great, but they have a group function. So, we all have probably seen some medical TV show or something, code blue. You can do it with Vocera, right? So all the appropriate staff are getting notified simultaneously, and it's a low impact on the network. So now I will say Vocera traditionally was using Spark Stensmo, which we went over in some prior sections, to deal with that. So if you didn't understand this next topic, well, Spark Stensmo is going to make it work anyway in the campus, right? So the controllers are on the campus, the APs are on the campus. They are all, inside the WAN boundary, right? They're all on the LAN side. You can make it work. So we're going to go on to, going beyond. Dense mode was great, a great start. You look at a lot of these technologies. I mean, look at RIP as a routing protocol. It's lousy. It is, right? So in RIP v1, everything's classful. I have to broadcast. So I'm spamming everyone on a segment like, here's RIP updates. Oh, you don't know what they are? Whatever, you're going to drop them. Right. As a broadcast, they're going to have to process it all the way up, and they're going to see UDP, whatever the port number is, and then drop it. Right. So, and it picks some pretty lousy paths. It's like, oh, that little T1 you have that connects these two sites directly, that's the better path than these high bandwidth links that are a little more indirect, that'll get there in much less delay, much faster, more traffic, right? It is. So, we make an effort at it. So we made a lot of improvements, and this is, let's get going. This is my regular show. Yeah, certifications, like all that stuff on the back wall, right back there. A bunch of this stuff, you can look them up in detail. What's current there. Sometime I got to put together like a show of all these crazy things, compact certified rack installer. Why? Because I can do it for 99 bucks. I had all my guys get certified rack installers. I thought it would help them. And I remember after I left that company, I came back later and they were doing these really messed up rack installs. And I'm like, I got you training. Like, there you go. But it'd be kind of fun. It also show like is the hair kind of is a giveaway, but you know, hey, and I'm used to Silicon Valley, you know, where we used to joke, you're over age 12. They're like, you don't know anything because, you know, you're not current. Whatever. Um, and I just put in a big disclaimer, and I was like, look, this is my own stuff. I'm working this. Nobody's paying me to do it. You know, great. What multicast is group communication. Group is 0 or more computers. It's old. It's old now. That's what, 35 years? Yeah, 35 years. Right? Yeah, 35. Been through a lot in the meantime. Here's the question. Okay. Um, there's kind of two things you're focused on right now. One of them is about how source specific works. There's some stuff I don't go into a lot of detail, mostly because I haven't done that much with source specific. So there is more to it that I may not know all the ins and outs right at the moment because I, you know, haven't had to do a lot of implementations. And then the other question is for everything else, bidirectional, any source multicast, how do routers learn about rendezvous points? Okay. And then I want you to start thinking about what method's going to work best for your network. And I know, you know, there's a lot to kind of take in and absorb over the course now of almost 2 weeks. So, but you know, these are the kind of questions, and bookmark this question, right? Bookmark it, watch the series again, you know, pick up those Cisco books. Their titles are easy, Multicast, and Multicast Volume 2. That, you know, start digging through those, and work with your vendor's documentation and figuring out what you need, and I think you can come up with a pretty decent design. Now, I gotta say, I have this terror of messing up. I do. It's terrible. It can be debilitating at times. I'm like, oh, I did this wrong. I will say, having worked now in tech long enough, there are particularly my early designs. You go back far enough where I tell you about, you know, running frame relay and ridiculously small bandwidth. There's a lot I do differently from that because I know a lot more. Now, of course, I'd have to sort out and, you know, well, okay, we couldn't have done that then because this technology didn't exist or whatever. Yeah, there's that. But, you know, as I've gotten more information, you're like, oh, I would have done this differently. I would have done that differently. And that's okay. The key questions are, you know, are you making it work? Is it stable and reliable? And is it supportable? If the working part, I mean, the not working is a problem. And when you're really the not working and you can't get beyond that, that's when you're gonna need help, right? So switching out products or looking at a different technology approach or bringing in consulting help. Okay, and moving into that reliable and supportable, the last two, you're doing really well. Could it be better? I'm sure it can, but you're getting down to where, you know, reliability is there and supportability is there. You're doing good. Yep, this is just your argument, right? So, you know, hey, guy comes, I want to double the scope. We need to do more sites, or we're going to do, you know, higher bandwidth, whatever. You're like, cool, no problem, happy to do it. Need more time, more sites, more time, right? Take more hours to install gear, do whatever I got to do, changes, right? And I need more money. You change any one leg on the stool, on this 3-legged stool, the other's got to change. Just want to keep emphasizing that because, yeah, people come at you, and I swear to you, of like, well, we're gonna do it faster. Why isn't it cheaper? Because you're taking less time. It's like, no, the amount of hours is the same. We're just compacting it, which means that other things happen, like needing to pay overtime or things like off-hours rates for consultants that add to cost, right? But people are like, well, I don't understand. Right. That's why I keep emphasizing this. I think it's an important concept, not multicast related directly. Right. But if they tell you, hey, you know, originally the scope was you're going to touch, you know, X, you know, 10 sites, now you're doing 100. Right. Need more time, need more money. Okay. Visual presentation, why multicast, right? One stream through each interested link, period. No matter how many receivers are downstream. One. Okay. And that, again, I thought just is another visual of, yeah, from the perspective of that machine, bandwidth is absolutely flat. I send one stream. Everything else with Unicast, I gotta keep sending more and more streams. Bandwidth keeps going up. I forget what I use the reference bandwidth for that, but whatever it is, doesn't matter. Again, you're spotting it, right? So you're looking at some NetFlow stuff and you see, hey, I see these addresses in that 224 to 239 range. That's multicast traffic. What is it? And why is it there? Okay, remember you can go to IANA and look up registrations on stuff. So if it is the commonly defined OSPF EIGRP, there's a HP printer discovery, SSDP. There's a whole bunch of stuff that's very Googleable. And that can help you figure out what's going on. There's a bunch of other stuff you're going to see. It could be in the ranges that IANA is saying is reserved. You'll see this thing. Well, it's going to take a lot more research to figure out what it is, because that means somebody built an app, installed an app somewhere in your network, is running multicast, and you haven't documented it, so you don't know what it is. And always a destination, never a source. Always a destination, never a source. Different flavors of IGMP. So the ones we're going to focus on is V2, V3, right? And MLD V1, V2. Why? Well, because the leave is huge. We don't leave traffic hanging, broadcasting for a while into a segment when there are no clients that are interested in the traffic anymore. There's a method for them to say, I'm done. And there's a method for them to figure out there's no other hosts that want that traffic, right? And in V3, I can cut out RPs completely. I can have a complete out-of-band solution that I'm saying, go to this host on this group, and you'll get the traffic you want, right? But there's a method to that. We're talking about that today. So we're getting to actual real Cisco commands. Hey, they do vary across platforms, right? So Nexus, the ASR series, the ISRs, they all look different, subtly at times. So for example, with ASRs, that multipath command isn't exactly in global. It's a subcommand to IP multicast routing. Cisco did it that way, right? If you have been on with Cisco a long time, you'll remember that Cisco's done a lot of acquisitions, and it was funny because the first generation acquisition was pretty much the native whatever they bought, and then it was slowly Ciscoized over time, but it was often frustratingly weird, the differences, right? So if it's not working the way you think it does, go to the command reference, figure out what's different about it. Basic is multicast is not turned on by default. You may need, certainly with Nexus, you're turning on multicast feature. And certainly with like your switch platforms, things like Landlight, I doubt Landlight does any kind of multicast. You may not be able to get all the features you're expecting depending on your license level. And so you may need to go back to Cisco. And certainly there was a day when it was easier to get into CCO, and it was, you could cheat and put yourself at financial risk, and well, I'm going to run the enterprise code or whatever. Now you can test out. So if you want to test out features, yes, you can license level blah, and then test out a feature. Right? Make sure it does what you want, and that you can do it that way. But you do need now, with the new platforms, to go through Cisco's licensing and get properly licensed. Right? They've now made it so it won't work anymore. And then the multipath command, I've talked about that. I like to emphasize that it's a situations with there's a possible multipath that it's a loop prevention. We're blocking traffic that's not coming in the interface I expected, and it's only one direction. So with particularly equal cost multipathing, there's two possible routes, and I'm blocking the second route. I'm blocking traffic coming in that way. I can only do one way with multicast. So I either have to wait the route so there is only one route, or I need to turn on multipath. And the multipath, as far as I can tell, it doesn't introduce any significant risk. In the designs I've done, the large implementations I've done with multipath, I haven't seen that give us any problems. So you know, I highly encourage it. Certainly, you know, if you're in a high risk environment, that, you know, do your homework, make sure that multipath makes sense for you, or, you know, do the other design pieces. Make sure that the paths are highly deterministic, so that you're saying there's always only one path, only one preferred unicast path. Unicast is going to go this way unless there's failures. Then it can reroute. Okay. Source specifics. I said I was going to talk about that one. There's an IANA reserve range 232.0.0.0. So it's supposed to be registered range. You know, I have the source specific thing. Here's the group. You can define other ranges inside in your configurations, and I should have put the command in here. And I'll revise this. I'll bring it up tomorrow. That you tell it, hey, these are source specific. Don't look for an RP. There's going to be another method to figure out where it goes, right? And so there is no RP, so there's no shared trees. They're all source trees. Now, you have a lot of these conversations going through any device. Yeah, you're taking up more memory because I have a bigger MROUT table. My MRIB, MFib is bigger, right? It's a risk. And with IGMP, you can actually do source specific without using IGMP v3, but you're now putting all the work on the router. If you have IGMP v3 turned on and it is not turned on by default, you have to enable it. That the receiver can tell the last hop router about the source it wants. They can say include this, include these, exclude those. It's an optional. It's either an include or an exclude. And to include null or exclude null is the same, or excuse me, exclude null is the same as I'll take anything. According to the documentation, I haven't done it this way. Only the last hop router needs to be configured for source specific. That I always set up my source specific configuration so it's set up along the path. Part of that was it allowed for easier auditing, so I can look for these commands. I could have as part of the config standards. Here's look for these, and if they're not there, flag it. So we'll fix it. But according to documentation, you only have to do the last hop router needs to be properly configured. Essentially, it's going to look the same, right? Because you have the last hop. It's going to be doing these PIM joins back to the source. So as long as the last hop knows what source you're looking for, you've told it that. That's the only one it needs to know. And then it's going to be doing joins back. Hey, I want this source on this group. I want this source on this group. And then it's going to add an S, G along the path, the unicast best path back to the first hop router. Which going from last to first, right? See, that's why it's on its head. Okay. And the pruning looks different. And unlike any source, there are some reasons you'll prune out the S, G entries in ASM. And then here is 3569 talking about source specific. So you can get into details if you're interested. And here it is. So global commands, IP, PIM, SSM, and the default says, hey, use that range here. Use that range for source specific. Everything else isn't. And I can also do it by an access list. So I can do, yeah, I did put the command in range and access list. So if I need to have a broader definition, so you may, for example, to do this properly in the 239 range, you may do something like 239.232, or if you're using that second octet to specify like a site, say for example, I can do 239.200, and then maybe I block out the third octet 232 to say, and that's my source specific. So if you're, for my site, if you're 239.200.232.0/24, that's in the access list, your source specific. Don't look for a rendezvous point. No rendezvous point, no shared tree. Okay. And you can do these SSM maps And you could do, one of the ways is you can query DNS. And here's the idea. I actually do kind of a reverse lookup. So a device falls in this range. Say it's in the default range, so it's 232 something. I do a reverse lookup. Well, I'm going to do, and maybe I did it in the next set of commands. Yes. So IP domain multicast, and then I give it a domain. I give it a prefix. So like mcast.eurodomain.com. So when I do this query DNS, I do essentially reverse lookup on that 232. So, whatever it is, 1.2.3.239 MCAS or 232 mcast.eurodomain.com, and it'll come back with an IP address for a source. That's one of the ways to find it. It happens in DNS. So it happens outside, it's out of band. This isn't a routing protocol. There isn't, we're using DNS, we're using other things, we're using maps, we're using some method to say that's your source. Go there. Right? And you can build maps. The command references will give you some examples of this. I haven't done much with this. The query DNS was one of the methods I used successfully, right? In partnership with my application guys, they do what they need to do. We together build, the DNS piece and configure the routers this way. And so in this example, this example is for static mapping. So I said, hey, don't query DNS, do this. Here's an access list. If I am doing DNS, and of course I have to do this, I actually have to have an IP name server. So there's some ways to do this, and let's have it on time. We're doing okay. Okay, and then and this one, configuring the interface to use IGMP. There's a couple different versions, and URD. Think of it as URLs. There's a special version of URLs. There's a way I can be using that to specify the group and source. I have not worked with these, so I can't speak to this in detail. Okay, so then we're going to flip topics entirely in this last 10 minutes or so. Feel free to ask questions, if you have about Source Specific. Source Specific, great. Works really well. If you build it well, there's not a lot that goes wrong, right? You obviously, you let people into your configs and people start changing configs, sure, it's going to break. I'll guarantee that. And, there are things that sometimes are out of your control. So for example, with DNS, say your server guys start moving the name servers around. So, we went from Windows, whatever, 2012, 2016, or whatever it is. And we moved the DNS servers. So now they're here and you're pointing at an old server. Well, yeah, it's going to break. It'll be pretty obvious. But you are with this depending on, and there are things too, if the source specific is really being driven by the outside app, if that stops working, if you're not getting the correct, this report, I want this group with this source, if that stops working, well, that's an application problem. But at times you may need to do things like packet captures and go, yeah, it should look like this and it's not. What broke on your application? Oh, we just did an upgrade on the app and it doesn't seem to be working right. Sure. Right. It's nice at times when you have full control, right? So I know in large organizations, touch my face again, in large organizations that, there can be these fairly high walls between the different groups. So it's like, well, my stuff works and they're saying it can't possibly be them and I can't think of what else. It can be challenging, but this is pretty darn reliable. So rendezvous points. So I talked about how they work. Spent a lot of time in the last 2 days just how do they work, right? And so how does the sender let the RP know that it's out there? How does the receiver connect to the RP and say, I want this traffic? One of the ways to know about it, and this is the thing I kept avoiding, was you can just define it statically. Hey, sure, fine. In a really small environment, this makes a ton of sense. Now, this override command, and this is going to be interesting. So it's an optional command. Well, the override is there because by default, it's going to take an automatic process over the manual. So unlike anything else, so you think of routing protocols, we give the highest weight to a static routing protocol. Highest weight to connected, and then second to static routes. So if I put in a static route and I have a BGP route or I have an EIGRP router where the static route takes precedence, I have to do something to override that, so I can put a distance so that it's I do what's called floating the route. This is actually backwards, that I don't pay attention to the static if I'm using these other methods we're going to talk about in a second, unless I put in the override. Now, really key, everybody's got to be defined going to the same RP. So if you have some sort of configuration management software, even if you're doing something just like backups and you could grab the data, one of the checks you're going to do, particularly in the static, is make sure that they're all consistent. They're present and consistent. Not present, not consistent, you're in trouble. That's a bad sign in some countries, sorry. And you can do some redundancy, and you can use what's called an anycast address. So I set up an extra loopback that's the same IP as another device, so that I can have multiple RPs. And I may have like say in my, if I've got what I like to call these ellipse designs. So it's kind of a star, but you've got two, a primary and a backup, or an active data centers, right? Everybody connects to both. So if I had to draw this, it would look like an ellipse, two things all connecting to these 2 points, okay? I could do this with both, and then we're going to see how that's going to be a problem. They all need to point to this. They need to have the same information. You're not. You're sending it to 2. There's a way to fix that. And then by default, if you don't use the group list, it thinks it's definitive for everything. So you just put an IP, PIM, RP address, blah, leave off the rest of this stuff. Well, I'm RP for everything possible in multicast. The SSM, when I SSM this IP, PIM, SSM default or range, yeah, it's going to take those out and go, okay, well, you're definitive for everything except for that source specific stuff. But that's what you're going to do. So you need to be careful. And if you drop in, you put in group list and you give it an ACL name and the ACL is not defined, it doesn't necessarily, in the ones I've seen, it doesn't necessarily give you an error. What it does, though, is it treats that null list really as the default range. You're thinking, well, because it doesn't exist. It's because it doesn't exist at all. There isn't even an implicit deny. There's just nothing. So it takes that as I'm it for everything. So be careful. You do need to check and make sure in a situation like this that if I've gone with static RPs, yeah, all the layer 3 devices that need to do multicast or in the path, multicast path, have this defined. They're pointing at the same IP address. This group list is defined. The ACL exists and is correct. And if necessary, I have the override turned on. Now for auto RP, this was Cisco's, one of the first things they said, no, in a big network, this is a gigantic pain in the backside. Easy to make a mistake. Now, with bigger networks, obviously you'll have things like, I'm more likely to have like configuration management software, more likely, not necessarily. And frankly, you can own all these tools that you want, and if no one's paying attention, then who cares? I just have a dashboard that says I'm, 1% compliant and nothing works. And then I'm like, oh, gee, I don't know what's going on. You're like, yes, you do. Your compliance is telling you you're a mess and you need to go in and fix it. So Cisco developed the Auto RP, Cisco proprietary. This needs to be turned on all your, and I said routers, and really I mean all layer 3 routing devices. Anything you're going to turn on multicast routing, you also turn on IPPIM Auto RP listener. It can still work without it. Sometimes, sort of, don't do it. And now, so this is the enabling command, IPPIM send RP announce. And I'm sending this out of interface. That interface is going to be, needs to be PIM enabled. And typically if I define this, at least in my experience, if I define this as an interface and it has been turned on, it'll come back and say, I can't do that. You're gonna get a clear error. It says, I can't do that. And loopbacks are best. This obviously, this is the typical thing, right? So I have an interface go down because I have like a physical layer problem. Now I'm no longer advertising an IP address, so I'm down. Now, if it was a one-legged stool, doesn't really matter if it's right, but I don't. If it's my RP, I really shouldn't have a one-legged stool. I should have more than one interface going out. And yeah, I could do say like a BVI, and or in some of the newer ones I can do real port channels. So I have 2 links and they're, have a single IP address. Let's not. And this scope is a TTL value. So how far do I want this to go? How far do I want my announcement? If it's for a single campus, it may be fairly small. If it's enterprise-wide, well, I may leave it at a default. I may set it to 255. In a group list, that's kind of like this one right up here. This is what am I authoritative for? It needs to be consistent. And overlapping can create interesting problems. So be careful how you do this. I can change the interval, and then bidirectional is I do bidirectional. And then this send RP discovery, well, this is about a mapping agent. So the mapping agent is the one who's telling everyone else about who the RPs are. This RP announce is about candidate RPs. So this is I can be the RP, and this is the one who sorts through. Now the mapping agents decide we're going to use this guy. We're going to use that guy. And the methods are based on IPs, the announced IPs. There's some limitations to that. There are some serious limitations to it. The thing I don't like about Auto RP is that in a lot of cases, it's just going to, it has a mind of its own, and that's bitten me more than once with Auto RP. Not really happy with Auto RP anymore. And let's see, do we have time? How are we doing? Now, pick up with BSR starting tomorrow, but these are basic set of commands. With these, right, you turned on, you turned on multicast routing, you turn on multipath because, well, it's a good thing to do. Now you're adding either static RP or you're going to do Auto RP. And so the IPPIM Auto RP listener. And the key thing on this, and I'll emphasize this one, so one of the problems you had was, well, so the Auto RP is announcing on a particular group. But if I'm using sparse mode, the only way I know where the source is I need to have an RP tell me where the source is. But I'm trying to find the RP. This is how I'm finding the RP. So therefore, this is circular. It's conundrum. It's sort of, I need the map to find the map. That's a problem. So when you turn on this IPPIM Auto RP listener, it takes 2 groups and it makes them sparse mode by default. And you're going to see those when you do a show IPM run, you're running Auto RP, you're going to see those. You're going to see the, what is it? It should be 224.0.0.39 and 40. You're going to see those pop up because that's all about auto RP. They're going to be running dense mode by default because that's going to allow I share to all my neighbors, and if they have IPPM auto RP listener turned on, great. I've been waiting for that. Great. So the send RP announce is going out. The mapping agent is sending out. It's like, hey, I have the RP for you. So as it sends, here we go. The RP announcer going out to mapping agents. Mapping agents are going out to all the listeners and saying, I got this. And it's crawling across the network, hop by hop by hop by hop, within the scope you've defined. And there's more to this. We're going to pick that up tomorrow. Hey, thanks for stopping in. Enjoy the rest of your day, and we will talk with you soon enough.